In this video, I'll show you how to solve the ALEKS problem called naming the shape of a molecule with one central atom and no octet rule exceptions. First thing that we're going to need to do is draw the Lewis structure of this molecule. You can't do this unless you're looking at Lewis structure. And in drawing the Lewis structure, step one is going to be to count up the number of valence electrons in the atom. Phosphorus is in column number 5, so it has 5 valence electrons. Fluorine is in column number 7, so each fluorine has 7 valence electrons. That's a total of 26 valence electrons. We start by drawing the first atom in the formula in the center, and we connect the 3 outer atoms to the central phosphorus. That used a total of 6 electrons, leaves us with 20. We'll use those 20 electrons to satisfy the octet rule for the outer atoms. Satisfying the octet rule for the outer atoms used 18 electrons. That leaves us with 2 more, and those last 2 electrons are going to go on the central atom. Now, we are being asked to come up with the shape of the molecule. The shape of the molecule is based on a combination of bonds and lone pairs that are on the central atom. And you probably have a table somewhere, or if you don't, you can look it up on the internet, a table that will give you the number of bonds and the number of lone pairs on the central atom, what that shape would be called. For this particular molecule, we have 3 bonds and 1 lone pair. When we have 3 bonds plus 1 lone pair, this particular shape is referred to as trigonal pyramidal. So again, what you're going to need to do, step 1, come up with a lone pair. Step 2, look at the central atom and count how many bonds you have and also how many lone pairs you have. And then step 3, consult some sort of resource, some sort of table that gives you all of the different possible combinations of bonds and lone pairs and what that particular shape is referred to.